You might think you know the answer to the simple question of why the sky is dark at night. The reason is because the sun is not there, which is why you hear it called dark. But don't be too sure. Look at this photo, there is a sun, but even so the space is still dark. The reason for this is that our world has an atmosphere. The white light from the sun is scattered by many particles as it travels through the Earth's atmosphere. This is how we get a blue sky. If we look at the photo again, we might want to rephrase our question as, why is space dark? If you didn't understand what I meant by that, don't worry, in this video we will delve into the answer to this question in depth. You'll see that if the universe is infinite and contains an infinite number of stars, meaning that there is an infinite amount of light coming towards us from all directions, then why is space dark? It doesn't have to be infinite. After all, our homes are surrounded by millions of galaxies. So if that's the case, why do we see a dark sky? Let's go on another journey, friends. This sky has been inspiring people to think, question, and admire for thousands of years. Astronomers have laid the foundations of astrophysics by observing the sun during the day and the rise of the moon and stars at night. They have named objects in the sky like planets and stars, and since the discovery and use of electricity in everyday life, especially for people living in cities, they have been deprived of this magnificent sky picture. I'm one of those people. I can rarely see stars in the sky at night because of the incredible light pollution we've created. For example, in 1994, a 6.7 magnitude earthquake struck Los Angeles, California. The aftermath was incredible, and electricity was cut off in every part of the city. During the power outage, many people left their homes and flooded the streets. The first thing they noticed was that it was dark everywhere. Los Angeles is normally a very bright and unruly city, but the people had never experienced such a complete power outage before. They were shocked and looked up at the sky, wondering what they had done. You could see silver with a small telescope, you could see Jesus as well as thousands of stars and galaxies in the Milky Way. But these numbers don't even begin to describe the number of stars in the Milky Way, which is estimated to be around 400 billion. Maybe not even 1 in a billion of them. I'm trying to make a point about the old view of the universe, where the universe was seen as static and unchanging. But in fact, that's not the case. In the last century, it was understood that if the universe had always existed, with infinite stars, all the truths we know would lead us to one of those infinite stars. Because the universe had a beginning and, even though those stars are millions of light years away, the time it takes for their light to reach us has already passed. So, all points in the sky should be bright, but we know that the universe did not always exist, and yet, even in our own galaxy alone, there are millions of stars, and even more throughout the entire universe. In fact, we know that there are 1,000 stars for every grain of sand on Earth. So why isn't the universe bright? It's because it's dark. This is called the paradox of the night sky. It's a serious question that scientists have been trying to answer for centuries. The first person to try to answer it was the English astronomer Thomas Diggers, a few years after the death of Copernicus in 1546. But I'll take you back a little further to show you how our understanding of the universe has evolved. In the 2nd century AD, the Greek philosopher Ptolemy wrote one of the most important books in the history of science, in which he incorrectly claimed that the sun revolved around the Earth. This model, which placed the Earth at the center of the universe, was the main model for astronomers everywhere for over 1,000 years. Then came Copernicus, the father of modern astronomy, who threw Ptolemy's Earth-centered model in the trash and switched the roles of the sun and Earth. But Copernicus also placed the Earth in a special place in the universe, and it wasn't until later that scientists like Galileo and Kepler showed that the Earth and other planets revolve around the sun, and that the sun is just one of billions of stars in the Milky Way galaxy. Then, in the 20th century, scientists discovered that the Milky Way is just one of billions of galaxies in the observable universe, and that the universe is expanding. And so, our understanding of the universe has evolved over time, but the question of why the night sky is dark is still an open question. The brighter stars were closer, while the dimmer ones were farther away. In that era, this idea was considered a revolution, imagining an infinite number of stars in an infinite space. And inevitably, the question arises, if the night is dark, but there is no paradox in the middle of all that hair, the lights of the distant stars would not be visible in the sky, as it was in Zurich at that time. In 1610, the German astronomer Johannes Kepler proposed another solution to the darkness of the night by explaining it as the end of the universe. The darkness between the stars is the darkness surrounding the outer wall of the universe, and a century later, the English astronomer Edmund Halley re-examined the question and reached the same conclusion as Kepler, that the universe is infinite, but the distant stars are too dim to be seen. That's why the night is dark. As you can see, scientists keep coming back to the same answer, which is actually quite logical, but not true. The first person to solve the question without giving this answer was the Swiss astronomer Jan Philipp Dieses, who made some assumptions. He assumed that on average, the brightness of stars is the same everywhere in the universe, and that all stars in the universe are arranged in layers, like the layers of an onion, and that these layers extend indefinitely in our group. Then, using geometric calculations, he proved that although the stars in each layer are brighter, the outer layers are larger and therefore contain more stars, so these two effects balance out and the total brightness of each layer is equal to the total brightness of the other layers. So, the fact that distant stars are dim doesn't change anything. It means that there are more stars, which means more light. So, the only explanation left was that the universe could not be infinite. If it were, the nights would not be dark. And then, in 1823, the person who gave the paradox its name, Henry Hulbert, came on stage, and in an article he published, he explained the darkness of the night sky differently, by proposing that space is also filled with interstellar gas and dust, which blocks the light from distant stars. However, today we know that as time goes by, these gases and dusts will eventually dissipate and the light from distant stars will shine through. Actually, all the structures in this spiral cloud are in and of themselves a galaxy. Even more interesting is that, aside from the local group, all the classes are moving away from Earth at a speed proportionate to their distance from us. Regardless of the direction we point our telescope, we observe the same phenomenon. Friedman's idea of an expanding universe has been confirmed with a pull of logic that takes into account that the universe should have been smaller in the past. Therefore, at one point in the past, all the galaxies in the universe must have been compressed, and at an earlier point they must have all merged at a single point, that point being the Big Bang. As we know today, the space between galaxies is constantly expanding, and the rate of expansion is increasing. It appears that the effect of gravitational pull is slowing down the expansion in some places, but in others it is causing it to accelerate. Scientists today call this dark energy. In a way, Einstein was right. His addition of the cosmological constant to his equations keeps the universe in a steady state and allows for expansion. The Big Bang is not just based on observations of the cosmic microwave background radiation, but on a variety of other pieces of evidence as well. We can finally answer the paradox that we have been searching for from the beginning: space is dark because the universe has a past. The universe was created in the Big Bang and is constantly expanding, and there is a limit to the speed of light, even relative to cosmic dimensions. When we think about it this way, the speed of light becomes less significant. If we imagine that a light beam set out from a distant galaxy towards Earth when the universe was much younger and smaller, the beam would have to travel an increasingly longer distance as the universe expands. So, the distance that the light beam has to travel increases as the universe expands. This is the reason for the darkness.